Hi. Early in the set of lectures, I talked about how in the past Japan had had extremely high levels of growth. Remember in the 1950s to 1970s, early 1970s, you see that Japan has growth rates that hang out in the 7 to 8% range. I also talked about how China is currently experiencing levels of growth that are equally high in the same sort of range, 8 to 9%. And there's a question, can China continue to sustain those levels of growth? But what we want to see is we want to use our very simple growth model to see why countries like Japan in the post-war period can have incredibly high growth, why China during this era of industrialization can have incredibly high growth, but why would we should be somewhat dubious about the prospects of China being able to maintain these levels of growth unless they're able to somehow have massive increases in technological improvement. So we'll see that if you're catching up to other countries, then it's highly likely that you can experience super high growth levels, just like the ones we see here. But once you've caught up to other countries, it's going to be hard to maintain those growth levels unless you somehow can support massive amounts of innovation. So let's see how this works. And we're going to do it just by doing some math. So we're going to use slightly different numbers than we used before, but the exact same argument. So here what we're going to do is we're going to assume that the savings rate is 20%, the depreciation rate is 10%, and we're also going to assume a much larger economy, so we get bigger numbers. So instead of assuming that there's 100 people, so that the square root of that is 10, we're going to assume that there's 10,000 people, so that the square root is 100. We're also going to start with a lot more machines. We're going to start with 3,600 machines as opposed to just 6. So this is a bigger economy, and that'll allow us to get slightly more reasonable numbers when we work through the math. So remember how this works, right? What we do is we compute total output, we see how many new machines then get invested in, we see how many machines get depreciated, we solve for the new number of machines, and after we solve for the new number of machines, then we can solve for the output next period. So let's get started. Here we go. 3,600 machines, so output is 100 times the square root of 3,600, so that's 100 times 60, so that means output is 6,000. So let's think of that as per capita income of $6,000. So how much are they going to invest? Well, investment is going to be 0.2 times 6,000. So that's 1,200. So they're going to invest in 1,200 new machines. But depreciation is 10% of the existing machines of 3,600, which is 360. So if we net those out, we get 840 new machines. And with those 840 new machines, that means the new machines in the next period is going to be 4,440. So that's what we've got the first period. Output is 6,000, and now they've got 4,440 new machines. So let's go to the next period. In the next period, we're going to start out with 4,440 machines. And what we're going to do is then we're going to compute the output in this setting. So here we go. The square root of 4,440 is approximately 67. So we're going to get 100 times the square root of 4,440, which is 100 times 67, which is 6,700. So our investment in new machines is going to be 20% of that, which is going to be 1,340. And our depreciation is going to be, or 10% of this, which is roughly 440. So we're going to invest in about 900 new machines. So the new machines next time is going to be 5,340. What we can also do is we can look at what is our growth rate. So currently we've got $6,700 per person. Before we had a GDP of 6,000, so that's roughly 11% growth. So this is a growth rate not unlike, a little bit higher, but not unlike what we currently see in China. We went from 6,000 to 6,700, and now we've got 5,340 machines. Let's go ahead one more period. We've now got 5,340 machines. We want to ask, what's output going to be, and what's growth going to be? This is just some very basic math. So if we take the output, it's 100 times the square root of 5,340. I'll write that out again. That's going to be 100 times, turns out, again, if you do this in your head, it's about 73. So that's 7,300. That's going to be GDP per capita. Investment in new machines is 20% of that, which is 1,460. That's 20% of 7,300. And depreciation is 10%, which is 530. So we're going to add 930 new machines, which is going to give us 6,270 new machines. What's our growth rate? Well, our growth rate, it was 6,700 before, now it's 7,300, so it went up 600, which is about 8 to 9%. So what we look at is, in the previous period we had 11% growth, now we've got 9% growth. So what we're seeing is consistently high levels of growth because of the fact that relative to how much labor you've got, the amount of capital is pretty low. So just by investing and saving, you can maintain fairly high levels of growth. Now let's jump ahead. Let's suppose that we've been accumulating capital. We've gone from 3,600 machines to 4,400 machines to 5,300 machines to 6,200 machines. And now we're all the way up to 10,000 machines. We can ask what's going to happen to output, and we can ask even what's going to happen to growth. So let's again do the math. The output is going to be 100 times the square root of 10,000, which is 100. So that means now per capita GDP, let's just say, is 10,000. What is investment going to be? Investment is going to be 20% of that, which is 2,000. But what is depreciation going to be? Depreciation is 10% of 10,000 machines, which is 1,000. So that now we're going to have 11,000 machines next period. Well, if we have 11,000 machines next period, we can ask what's growth going to be? Well, that's going to be 100 times the square root of 11,000 is what GDP is going to be. So that's going to be 100 times approximately 105, which is 10,500. So GDP is going to go from 10,000 to 10,500. But what sort of growth rate is that? Well, that's only 5% growth. So what you can see is when we went from 3,000 to 4,000 to 5,000 to 6,000, during that period, the economy is sustaining 10, 11, 8, 9% growth, really high growth rates, just like those growth rates we're seeing in China. Once the number of machines gets to 10,000, now suddenly the growth rate falls to 5%. But we're still adding, notice we're still adding net 1,000 machines. Well, let's keep going. Let's go ahead another 10, 20 years. And let's suppose now the economy's got 22,500 machines, and let's ask what happens here. What's total output going to be? Well, that's going to be 100 times the square root of 22.5, which is 100 times 150. So now we've got 15,000 per capita GDP. That's really good. How much are we going to invest? Well, investment is going to be 20% of that, which is 3,000, which is a lot of new machines. But what's depreciation going to be? It's going to be 10% of that, which is of the 22,000 machines we have, which is 2,250 machines. So that means net we add 750 machines. So that gives us 23,250 machines. Well, now we can ask what's our output going to be next period? Well, next period our output's going to be 100 times the square root of 23,250. Well, how much is that? Well, that's 15,250 ballpark. So now GDP's only gone up 250, and that's really like just a 1 to 2% increase. So growth is now in the 1 to 2% range. So we've seen this economy. Let's step all the way back a second. When we started out with 3,600 machines, output was 6,000. Then we had 11% growth. Then we had 8 to 9% growth. So this economy is growing at a fairly fast clip. Once it gets to 10,000 machines, though, now GDP only grows at 5%. And once it gets to 22,000 machines, now GDP only grows at 1 to 2%. What's going on? Well, remember our curve. Output, if we have a fixed technology, is going to be concave. So there's this region here where maybe you see 10% growth. Early on, when you don't have enough capital, given your amount of labor, you can get massive amounts of growth. But once you get in this region here, growth is going to fall to 1, 2%. It's going to fall off unless, right, remember from our model, unless you get lots of investment in new technology. So if you look at a country like China with really high growth rates, you can ask, what's causing that? And you can think, well, maybe what's causing it is they don't have enough capital given how much labor they've got. In the case of China, that's true. So they're at this part of the curve, so they're experiencing incredibly high growth. When they get to this part of the curve, then most likely you're not going to see this same sort of high growth rate. It's going to look a lot more like the picture in Japan. So for them to sustain high growth, they can't just continue to pour money into capital. What they're going to need to do is they're going to need to change technology. They're going to need A to increase. Now, increases in A necessary to keep up 8 to 9% growth just have never been seen before. So it'd be remarkable if technological advances occur at such a rate that they can maintain this level of growth once their capital levels get to the same level of other countries. What the model tells us is we're much more likely to see China follow a path similar to Japan, where we see high growth rates for a period, but then as capital accumulates, those growth rates fall over time. So what have we done? What we've done has been kind of fun. We've taken a very simple growth model, solar growth model. We've looked at data from China and Japan and seen how China has these incredibly high growth rates now. Japan used to have incredibly high growth rates. And we've seen from our model that if a country is undercapitalized, if their levels of capital are low relative to the amount of labor they've got, then you can sustain super high growth rates for quite a while as you accumulate capital. But once your capital levels become sort of appropriate for the technology, your growth rate's going to fall off. And the only way you can sustain that growth rate is through technological innovation, by driving up in Solo's model that parameter A. This doesn't mean that China is not going to continue to have growth, or that Japan is all growth will end, or that the United States or Europe all growth is going to end. What it says is there's two different ways to think about growth. One type of growth, what we're seeing in China now and what we saw in Japan post-war and what we saw in Europe and the United States post-war, is growth that occurs through capital accumulation. Another type of growth, which is what we see in the United States, in Japan and Europe now, but not in China, occurs from technological advances, not from buildup of capital. And as you advance technology and increase that A term, then it makes sense to buy more capital, but different types of capital, and that's what drives growth. Okay, a lot going on here, a lot of fun though, right? What we're going to talk about next, in the final lecture, is why then are some countries poor? This seems to make a lot of sense. Just invest in capital. As you invest in capital, you get lots of growth, and you catch up with everybody else. Why is it still the case that some countries are poor if we understand where growth comes from? Thanks.